Okay, good day. This is Honors Algebra 2. I'm Mr. McCully, and this is the video presentation for section 10-2 on arithmetic sequences and series. So let's get to it. Today we're going to write arithmetic sequences as functions. We're going to use summation notation to write arithmetic sequences and series, and then we're going to find the sum of an arithmetic series. Okay, so first off, the general equation for an arithmetic sequence is the nth term is the common difference times n minus 1 plus the original term. You might see this as something that you've seen before, and we can just generalize here. This is a linear equation, like we said in the last section. You can think of this as y equals mx plus b, and once we simplify it down, we'll get that every time. And so a arithmetic sequence can be written as a linear expression, and this is the one that we use to set it up, and then we'll simplify it a little bit. All right, so first thing it says, write the equation for the nth term of the given arithmetic sequence. Well, that's going to use the equation that we just had right here. So what we're going to do is we are going to figure out, and again, it's let's use the right tool. A sub n equals d times n minus 1 plus a sub 1. So here is my a sub 1, so we'll plug that in there. We need to figure out what the common difference is. And so when I go from 15 to 13, what am I adding here? Well, I am adding -2, and then I add -2 to go from 13 to 11, -2. So my common difference is -2. So I'm just going to come over here. I'm going to go a sub n equals -2 times n minus 1 plus 15. So I need to simplify. I'm going to go a sub n, and then I'm going to distribute. So -2 times n is -2n, and then -2 times -1 is +2, and then we'll have 15, and then our final answer, a sub n equals -2n plus 17. So when I start plugging in the counting numbers, 1 times -2 is -2, plus 17 is 15. The second term right there, 2 times -2 would be -14 plus 17 is 13, so I feel fairly confident that that is the correct answer. The process of finding arithmetic means can be used for finding the missing terms in a sequence. So as an example, find the missing terms of the given arithmetic sequence. So I have 1, 2, 3 terms that I'm missing here that I have to find. And if I go through it this way, we'll say this is the first term, this is a sub 1, and 1, 2, 3, 4, 5, this will be a sub 5. All right, so here's what I'm going to do. I'm going to say that a sub n equals d times n minus 1 plus a sub 1. Well, here's the thing. I know what a sub 1 is. It's -6. If this is the fifth term, then a sub 5 is going to equal d times 5 minus 1 plus a sub 1. So I'm just going to plug in all of those numbers. I'm going to say here is my 10 for a sub 5, and then I'll have d, and then since this is a sub 5, n is 5 minus the 1, and then plug in a sub 1, which we know to be -6, and the only variable that's left now is d. Well, that's good, because now I'm going to simplify in here. I don't have to distribute because there's no variables. So I'm going to go 10 equals 4d minus 6, and then I'll add 6 to both sides. So I'll have 16 equals 4d. That means d is going to equal to 4. All right. Now we could do this two ways. We could just do it in our heads and say the common difference is 4, so I'm going to add 4 to each successive term, which is perfectly fine. Or you could go a sub n is now 4 times n minus 1 plus -6, and go a sub n equals 4n minus 4 minus 6. A sub n equals 4 minus 10, or 4n minus 10, excuse me. And then just start plugging in the numbers. So I need 2, 3, and 4, but either way is fine. So let's just do it the easy way and say the missing terms since we know the common difference is 4, 4 and negative 6 would be negative 2. Negative 2 and 4 would be positive 2. Positive 2 and 4 would be 6, and then 6 and 4 would be 10. That makes me feel good that I've got all the values. All right, a series. A series is formed when the terms of a sequence are added together. So an arithmetic series is the sum of the terms in an arithmetic sequence. The nth partial sum is the sum of the first n terms in a series. So let's take a look at a series. So let's go 1 plus 3 plus 5 plus 7 plus 9 plus 11. All right. So if I think about this thing, this here is an arithmetic series. And its common difference is 2. All right. And so if I wanted to say, what is the fifth partial sum? All right. The fifth partial sum is essentially the sum of the first 5 terms. All right. So 1, 2, 3, 4, 5. 1 plus 3 is 4. 4 plus 5 is 9. 9 and 17 is, or 7 is 16. 16 and 9 is 25. So 1 plus 3 plus 5 plus 7 plus 9 is 25. So 4, 9, 9, 16, 16, and 9, 25. I'm confident with that. That's good. All right. Now, that's okay if the series is small, but if you want to find the nth partial sum, there is an equation so that we could figure out, we can add up a bunch of values real quickly, where S is the nth partial sum, N is the number of terms, A sub 1 is the first term, and A sub N is the nth term. So here's an example. Find the sum of the first 500 even natural numbers, okay? Well, if I talk about even numbers, it'll be 2 plus 4 plus 6 plus 8 plus dot, 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 all the way up to 500. Now, oops, that's wrong. I don't know, because that says the first 500 natural numbers. So I don't even know what the 500th even number is. I'm going to assume it's 1,000. But if I didn't know that, what we could do is we could say A sub n is equal, this common difference here is going to be 2 because every even number has a difference of 2 in it, n minus 1, and then the first term was 2, so A sub n equals 2 n minus 2 plus 2, A sub n equals 2n. And so the 500th even number, A sub 500, would be 2 times 500. So I was right, it's 1,000. All right. So if I want to sum those up, the 500th partial sum, if I use this equation from the previous page, will be, there are 500 terms. The first term is 2. The last term is 1,000 all over 2. And I'm not going to try and do that in my head. So 500 times 1,002 divided by 2. If I added those up, it'd be 25, 250, 500. So it's just 250, 2,050, 250,500. That's what I want to say. All right. Looking good. All right, next we have summation notation. So summation notation is an easy way to quickly write a series in a more compact form. And it has these 4 parts. So I is going to be the index, and your formula, the equation that you figure out to, or you use to figure out the terms in the series, is going to be defined by this variable. Now, it doesn't have to be I, it could be X, it could be something else. But the value here must be a numerical value, and it's the lower bound. This value up here is the upper bound, and I have n there because it could be as big as you want it to be. The lower bound doesn't have to start at 1, but most often does. And what this essentially says is, it says take all of the counting numbers from 1 to n and plug it into this formula and then add all of those results up. All right. So if I were to talk about this thing, it says write the following series in summation notation. All right. So first thing, I need my sigma here, and that's what this Greek symbol is. And I'm going to say it's from I equals 1. Okay, there are 1, 2, 3, 4, 5, 6, 7, 8 terms. 8 terms. So my upper bound is going to be 8. All right. Now the only thing that I need to do now is find the equation for what I'm going to put out here. And that equation is just the equation for how to figure out the terms in the sequence, which we've already done. This thing here has a common difference of 2 and a first term of 3. So if I go a sub n equals, it'll be 2 times n minus 1 plus 3. And so a sub n equals 2n minus 2 plus 3. So I get a sub n equals 2n minus 1, or actually it should be plus 1 as my final answer. And so this expression here is going to go, that is your formula for the summation. So let's see here, I'll get, it'll be 2n plus 1, and that is my final answer for writing that series in summation notation. Finally, it says find the sum of this series. Okay, well, clearly, since this is linear, since the formula is linear, the series must be arithmetic. All right, so I'm going to use the formula S sub n equals n times a sub 1 plus a sub n all over 2. All right, because this is the sum of an arithmetic series, which this defines. So I have to figure out what n, a sub 1, and a sub n is to adequately add this. Now, since it starts at 1 and goes to 200, there are 200 terms in this series. To calculate the first one, a sub 1 is going to be 3 times 1 plus 2. I'm just taking that equation there and I'm calculating that first term. So I've got 3 plus 2 is going to be 5, so that first term is going to be 5. And then my last term here, since n is 200, a sub 200 will be that last term. 3 times 200 plus 2 will be 602. The 200th partial sum will be, there are 200 terms. The first one is 5. The last one is 602. And that's going to be all over 2. So again, we'll just grab our graphing calculator. 200 times, what did I say? 5 plus 602, all divided by 2. Let's check my work. I got that. Okay. Hit enter here, and that sum is 60,700. And that is all I've got for today, folks. So the Macaulay fun fact of the day, Mr. Macaulay is the oldest of 3. I have a brother, Sam, and a sister, Steph. As you can see, I don't look like either of them. I am the child of the milkman, as my father used to say. Well, that's all I got for today, folks. Have a good day. Bye.